One of my favorite topics is understanding remainders by using models. Many articles have been written about it, and it's a kind of thing where if you actually see it, it becomes much more understandable. And it's not about just getting a remainder, it's about understanding what a remainder represents. So we're going to do modeling to show 3 divided by 2/3. And what we're going to do is I'm going to draw 3 rectangles to represent our dividend. And because I'm dividing it into groups of 2/3, I'm going to divide each rectangle into thirds. And of course, I'm going to label. And here we go. So, what am I looking for here? I'm looking for, and this is very important, I'm looking for how many groups of 2/3 are in 3. Okay? And so here we go. So I have one group. I'm not going to number it. 2 groups. 3 groups. 4. Okay. So I know that I can make 4 whole groups, but I have one piece left. And so you may think that my answer would be 4 and 1/3, because after all, the piece that's left is 1/3. And that's where the discussion comes in. Because if you remember, I said that this is an important question. Why? Because we want to know how many groups there are in 3. And what does a group mean? A group in this case means 2/3. Each piece is a third. So a group is 2 pieces. Now, if we look at it that way, then I have 4 full groups. And if a full group is 2 pieces and I have 1 piece, that means that I have 1 out of 2 pieces, or half of a group, and so my answer is going to be 4.5. So the half means half a group of 2/3, even though it looks like that one leftover piece is 1/3. And if you use the algorithm, we're going to do 3/1 divided by 2/3. And I like to draw a box around what's going to change and leave my dividend out here. So division becomes multiplication. 2/3 becomes its reciprocal, which is 3/2. And you get 9/2, which magically is 4 1/2, which you will see matches our modeling. A little different than you might think. Now let's look at a second example. 7/8 divided by 1/2. I'm going to model this a little bit differently. I'm going to make one box because 7/8 is less than 1 whole. So I'm going to divide it into eighths. And let's shade in 7/8. Okay, and let's label each of these is 1/8. And obviously there are 8/8 in 1 whole. Now I want to see how many halves there are in 7/8. So I'm going to actually draw a second model down here lined up. And that's going to be halves, right? This is a half, and this is a half. Now, look what happens. I know that there's one full group, right? There's one full group of 1/2 because half is 4/8. And now look what happens. I'm going to bring my lines down here to show eighths. And again, you can see that if 1/2 has 4/8, I only have 3 out of the 4 pieces. So I have one full group and then 3 out of the 4/8 that would make a whole group. All right, so let's see what we have here, and let's use the algorithm to make sure. So we have 7/8 divided by 1/2, and let's draw our box. Dividend stays the same. Division becomes multiplication. Fraction becomes its reciprocal. And we get 14/8 and 14/8. Okay, this goes in one time with 6 left over. And so we have 1 6/8, and 1 6/8 is obviously equal to 1 3/4. So again, let's do a different color. We have one whole group of 1/2, and then 3 out of the 4 pieces that it would take to make a whole group. And so we have 1 3/4. And that's the interesting twist on attempting to model fraction division when there is a remainder.